talk about Android malware can launch credential stuffing attacks by abusing accessibility service. Yes, that's a very long title. So before we actually implement the malware, we first need to go through a few boring stuff. So ATS malware, big name. If you search it like a simple Google search, you will find a lot of articles about ATS malware attacks, usually targeting financial institutions. Actually, 3 days ago, one of the popular malwares, which is called the Xenomorph, attacked like 300 banks in the US, and another one called Gigarat, which was just about a week and a half before, also like targeted a lot of banks in Spain. So it's an actual relevant threat. And what is ATS malware? ATS malware stands for Automatic Transfer System. So it's basically used to define a set of features which allow automatic transitions on the app, which means credential extraction, trying to transfer funds from the accounts, obtain MFA tokens from banks. And it's all done without any user interaction. So there are 4 main components to the ATS framework. Usually it contains a command and control center, which can interact with the malware on the devices remotely, which is done with, obviously, encrypted requests. Usually they choose a framework called Retrofit. It has the capability of information collection, which is the malware that sits on the Android device can basically like list all the apps that exist on the device, and then we know which apps we can target. There also is a command mechanism which the command control center can actively send commands to the malware that sits on the device remotely and control it from there. And of course, there is a capability of app interaction, the way that the malware interacts with the apps. So there's a simple graph about how ATS malware works. You infect the device with the Trojan, you establish connection with your C2 server, then you receive tailor-made scripts to specific apps that exist on the app to perform your attacks. And it could be like a lot of different attacks. For example, overlay attacks. You can steal session cookies, obtain passwords, transfer funds. So here are an example, like a simple overlay attack on an app that I made. So if a user wants to transfer funds, he will see this screen. But actually, this is a fake screen. This is an overlay injection that my ATS malware did. And this screen is what is actually happens behind this screen. And I'm transferring to myself 10,000 euros. So I'll be pretty rich. And then after that, he says, oh, hey, my account is drained. What do I do? Well, that was ATS malware. And another term that I want to go over is credential stuffing, which is basically automated stuffing of credentials into login forms. It usually works like this. Wow, big graph. Usually there's some kind of a breach from a website or credentials obtained from phishing attacks, which are being distributed on a dark net. These lists are called combo lists usually. And then an attacker can just take these combo lists, and because a lot of people use the same username and passwords to almost everything, he can just run on a bunch of sites and do web injections with these username and passwords. And as you can see here, the SpongeBob username is actually reusing his username and password quite a bit. So that is credential stuffing. And just to like show you how easy it is, I did a simple Telegram search for a combo list, and I received like thousands of groups which offer free combo lists. You can even pay to get higher grade combo lists. And then I just went to a random cracking forum, typed combo tools, which are checkers that check the combo list on different apps and sites. So I got like 12 pages or free checkers that I can use, and then basically match the combos and can sell the data, drain accounts, do whatever I want. And bunnies, yeah, who doesn't like bunnies? So I always wanted to put a bunny picture in a presentation. Okay, so now let's implement the malware. A few disclaimers. I use like an open source GitHub like shopping example app to do this malware, but this malware will probably work on a lot of like really popular consumer apps, even here in the Philippines. And this is all public Android API, so I didn't use some sort of exploits or 0 days. And please don't do this for malicious purposes. Okay, so first we need to create an Android app, which we will just create a service. Why we choose to create a service? Because service can run in background all the time in Android devices. So for that service, we'll give it the permission, bind accessibility service, which will allow us to do some stuff. We will talk about it more later. Here we're talking about it. So accessibility service. Accessibility service is an API that allows Android developers to implement accessibility features for disabled people. So, for example, show bigger text for people with hard sight. So how this works, it gives you a callback that is called onAccessibility event, which you can register to, and then you can get a bunch of accessibility events that are basically indications on UI transitions. So any UI transition that is happening on the screen, you can get an event on that. So you can see something was clicked, text was changed, a view was scrolled, like everything that happens on the screen, you get event about that. So that actually also how most of Android keyloggers work. They abuse this API to keylog your devices. So, So now we simply just initialize our accessibility service, throw in a bunch of flags just so we get all the types of events, all types of accessibility events from all the apps. And then we need to start the attack on our app. So firstly, we need to launch our app. Remember, we are in a service. We are not the app itself. We are a service that wants to launch the attack on another process in Android. So there is an API called Start Activity, which you can launch activities on Android. Activity is a class that basically represents a screen on Android. And we need to find the launcher activity. So I decompiled the app, and in the Android manifest XML, which is like an XML file that contains metadata, permissions, and activities for the app, for the Android operation system to read. And so I found the launcher activity. You can see the class name is com_victim_app_UI home activity. And basically, I created a component name with that class and started the activity from my service. Now, after we launched the app, we need to find the login activity, because that's what we want to credential stuff, right? So this is actually the API callback that we're going to listen to. It's called onAccessibility event. And now we need to find. So I found that if you press on the cart button below, you get into the login activity. So we need to get to that. But you probably ask yourself, okay, Lev, so with accessibility service, you only receive UI transitions. Yeah, you only listen to them. So how you can actually perform the UI actions yourself? So there's something called accessibility node tree, which is basically a parsing of the accessibility service of all the UI elements in the app. So there is a function called getRoot in active window, which gets you the root accessibility node of that activity. And with that, we can iterate on all over the children elements of the root activity, root accessibility node, to get the accessibility nodes of all the elements of the app, which looks like something like this. Yeah, big code. No, not so interesting. And once we found the cart button, which we can just filter by the resource name, which I found is just called cart button, pretty convenient, and just get the accessibility node and perform an action on it, action click, which is basically makes a click on the button that we found. So what happened here? The concept that I showed you here is called accessibility event chaining. So first, we had the home screen of our Android devices. Then we launched the activity of the app. And once we launched the activity of the app, we got our first accessibility event, which is window changed event. We can even get the class name of that event. And then we found our button, we performed an action, and we got content change event. So every time we can trigger another accessibility event in a new screen to perform the UI interactions on the next screen. So we can like chain the accessibility events, which is really powerful. So we already know how to iterate over all the screen. We simply need to find the login fields, which is like the enter number and the enter password, which is also done with getting the resource name and like getting the hint text that is written there. So once I identify that, I just type inside these fields and press click on the login. So what actually happened here? Again, we are a different process, a different service in the app, and we managed to fully automate another app outside our process with only one permission, and it's despite like Android hardened security regarding interaction between different apps. So I managed to perform like 5 to 7 login attempts per second, which if you multiply it by number of apps, number of devices, it can scale pretty hard. And it's also not a one-trick pony. So as I mentioned before, the ATS framework contains a C2 server, which from there we can send the scripts that will perform the attack. So for example here, sorry. So for example here, you will receive the package name that we want to launch and the path to login page, which basically contains the activities and the resource names that we need to find the login activity, and the combo list that we want to stuff. So really, really easy. We can perform it on any app which the device has. And this is like an example of some of the commands that Xenomorph uses. So also execute run, it runs the ATS module, it can obtain the cookies, it can do a bunch of stuff. Yeah, and now the last topic is DCS versus CCS. So we talked about credential stuffing, but we didn't talk about where we perform that credential stuffing. It can be either on my own devices, my own virtualized environment, my own device farm, or I can infect other devices with Trojans and do it remotely. So there are like pros and cons to each one. Of course, with CCS, with centralized credential stuffing, you have direct control of your devices. So you don't need to hide from a user, you don't need to infect anyone, but you need to work really hard to bypass detections, because it's basically like a bot, and bot is really easy to spot by the network, by the device validity. You need to really work hard to do that. But with DCS, decentralized credential stuffing, you have real device properties, real pass sessions with apps, pretty much bypassing most of the detections. But the only drawback is how you infect how do you infect the target devices with your Trojans. So if we would use DCS, how we would hide our operations from the end user that the malware is installed on. So one thing, there is something called Orientation Sensor Manager, which is basically I can listen on the device orientation, and once the device is facing down, I can perform our operation, which is like really funny. And when I turn the device up, I can simply press the home button, and it's like nothing happened. I also can, there is an Android API called Wake Lock, which is basically keeps the device awake. So if the user didn't manually press on the power button, I can just acquire this lock. The device will never go to sleep, and I can just go and perform this attack all over again. And of course, similar to the overlay attack shown before, once a user wants to try to log into an app, I can just simply stack a loading overlay, and behind that, try like 20 attempts of login stuffing attacks, and after a few seconds, make it disappear. So every time he tries to log in, I actually performing like 20 different logins. So matching combos on Android is easy. You just infect devices. Each device seems legit to the backend service of apps. It's the ideal maskings. You just match combos, sell the info, easy money. And about Appdome. So I'm a security team lead security research team lead in Appdome, and part of our mission is to protect from threats like DCS and other variants of malwares that abuse accessibility service. We have a bunch of cool features like obfuscation, encryption. We have a lot of cool stuff. You should come by our booth and ask more questions. And thank you very much.